Welcome to Bitstream. Today we'll be looking at this awesome oscilloscope with our special guest,
Nathan from Gooferking Science.
Let's take a look. For today's episode, we'll be looking at this BK Precision 1405 and learn how the XY mode works on it, as well as making it an awesome display, like it is right now. And we'll talk about what the future of it is.
So on my channel, I'm going to be doing an actual teardown of this CRT, and I'm going to do a more in-depth explanation of how the CRT actually works and how it functions on an atomic scale.
For the first part of the oscilloscope demonstration, I will be using the Analog Discovery 2. It says it's a high-performance, all-in-one USB oscilloscope and instrumentation system. So that's actually downplaying it a bit. It has an oscilloscope, a waveform generator, spectrum analyzer, voltmeter, logic analyzer. It really has a lot. This thing is so useful. On the oscilloscope, the Y channel corresponds with the up and down direction, and the X channel corresponds with the left and right. Now, to see how this all plays together, let us take a look at a sine wave on the y-axis. Now let's do the same thing on the x-axis. As you can see, as expected, it is moving along the x direction. Now what happens if we combine these two together? Looks kind of like an oval. Let's speed this up a bit. And as you can see, it does make a circle, with one axis following a sine wave and the other axis following a cosine wave, or sine wave shifted 90 degrees. It will make this pattern. By combining different patterns, you can make different shapes. For example, this shape. And if we do two of those, look, it makes a square. Combining these in different ways can give us more complicated shapes and more complicated even animations.
I like hot dog because it's not a dog. Do you like hot dog? I like hot dog because it's not a dog. Do you like hot dog? Eat hot dog. Hot dog burger, Coca-Cola. I like hot dog because it's not a dog. Do you like hot dog?
Just a side note, I did not create this video here. It was actually created by Jerobeam Fenderson, and I'll link this video in the description below. In the intro, I told you that we would be looking at this oscilloscope, which we did, although there is more to this video than just that. This is the introduction to the White Blaze architecture and AmberOS operating system, and this here is actually just a part of that bigger project.
Eat hot dog, hot dog burger, Coca-Cola. Hot dog, 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 hot dog.
The bigger project here is designing a computer from the ground up. White Blaze architecture is the hardware part of it, and AmberOS is the software part of it. And this oscilloscope that we're using in this video is going to be used as the display. My options for implementing and testing the hardware are fairly limited. I could make a couple boards like this that have like logic gate ICs on them, although that can get pretty expansive and honestly pretty expensive. So I think the better option in my case is to emulate the hardware design that I do out of the logic gates inside of an Arduino and go from there. The nice thing about using an Arduino for this is that I can use these physical pins here and be able to connect them to the emulated pins inside of the hardware design. So the basic structure of the White Blaze architecture should go like this. We have an Arduino, which is emulating the logic gates, and that is connected to a 16-bit memory module, and it will have a digital to analog converter also connected to the Arduino, and that is for the oscilloscope display, like we demonstrated earlier. There is actually a fairly simple solution for emulating a logic gate system inside of software. The way one would do this is they would have the logic gates in an array corresponding to their numbered gate here on the system. And so the computer will cycle through and update the outputs based on the inputs. And as long as it's going in a forward direction, it will be able to emulate it. A processor is pretty useless without instructions to follow.
You bet it is.
So the processor inside of the White Blaze architecture will follow the registers, which will be 256 bytes long.
256 bytes, isn't that like a whole meal?
And this is, of course, because it is 8-bit. The processor will also have access to write to and pull from VRAM and MRAM, at least that's what I'm calling it. VRAM and MRAM are pulling from this 16-bit memory module connected to the Arduino externally. And so the VRAM is actually going to be used for the oscilloscope. The VRAM will store the pixels that are going to be updated on the oscilloscope display. And the MRAM is just extra memory that it will have access to. The external byte will also be available to the CPU. This will be for anything extra that I want to hook into it, for example, a keyboard or anything else that I need. Because the AmberOS and the White Blaze architecture system are still in the planning phase, I will be updating them mostly on my blog, which you can access down on the description, and I will be doing videos of those later as I start working more with the hardware. Thanks for watching, guys. It was an absolute blast to work with Nathan. If you like high voltage, chemistry, anything like that, go check out his channel. I'll link it somewhere right here. If you liked this video, give it a good thumbs up. If you didn't, give it that good thumbs down. If you have anything to say to anyone in the world, put it in the comments below. And remember to subscribe. Thanks a lot. Are you blinking?
Okay.